Hey folks, welcome to another video. Today we're going to be jumping into a bit of a tutorial covering resource packs and a new item model definitions system that was introduced back in Minecraft 121.2. You used to be able to do some of this kind of stuff with item models and things like that, but it was definitely a lot more restricted. So wall change can sometimes be annoying. This system actually is really nice and allows us to have a lot more freedom as resource pack developers that we didn't used to have. The new possibilities of things you can achieve with this system are too numerous to list every one of them in detail, so I think for the sake of this video, it'll be much more useful to walk you guys through a few examples that will cover a good majority of the use cases, and then from there you can let your imaginations run wild with the possibilities. So over here I have a bit of a station set up with 3 examples that we'll cover in today's video of what you can achieve with our new item model definition system. The first one's going to be display context, which basically means that you can render different models dependent on the context that your model is being seen in. So you can see that for all of the models here in the GUI, they have a 2D animated sprite. But if I was to take this out of here and look at it in my hand in third person or first person, it's actually a 3D model, while the GUI still remains to be a 2D animated texture. This is a system that's been in the game for a little bit with things like the spyglass. That's why I had this here to show you, where inherently it had a 3D model when you would use it in your hand, but when it was on the ground or in your items in your inventory, it would be a 2D sprite, the same as what we're showing now. The change now is that system has been unlocked so that we can now apply that to whatever models, whatever items in the game that we would like to do that to. The second one will allow you to use components that are baked into an item. So in this case here, if you pick up an axolotl in a bucket, that bucket now has NBT component data saved to it, and we can call on that to do different things like this, like rendering a separate sprite for each color of axolotl. So it actually knows that there's a pink axolotl versus a gold axolotl that's in the bucket, which is pretty cool. There's lots of mods that would do this, but this is now a thing that you can do in vanilla, which is cool. And then the third one we'll cover today is the ability to use that same similar component system, but now we're going to be calling on stored enchantments or enchantments on items. So you can see here that I have a custom texture for when an enchanted book has fire aspect on it, a custom texture for when it has frostwalker, and then if it doesn't have either of those on it, if it's just another enchanted book, another enchantment, it'll default to the typical enchanted book texture. And I did want to show this here. This is the use case. This is what happens when you have multiple enchantments on one book. It will take hierarchically, that's a fun word, the first one that you enable in the item definition stuff. That'll make more sense later. We'll cover that in detail once we get to that point, but just wanted to highlight that. And then I have it here too where my pickaxe is showing whether I have fortune or silk touch on it just by denoting it with a separate little texture change. Just that, like, if you have 2 pickaxes that you run, you can see at a glance the difference between them. Thought that was a nice addition, but we'll cover that. And then it defaults to having no texture if neither of those enchantments are present. So those are the 3 use cases we're going to be covering today. Let's go ahead and jump over into our resource pack files to cover this first one here, looking at display context. So here we are in our resource pack for this tutorial. I'm not going to go too in-depth into how to create a resource pack because I'm under the assumption that if you are looking to do stuff like this, you probably already have at least some familiarity with setting up a resource pack and have done other things before. But the gist is that you're going to need, at a minimum, a pack.mc meta file that will include things like your pack format, and you can give it a description and whatnot. And then an assets folder, which is where all of our information, where our models and our textures and everything like that is going to live. This is the minimum, at least these 2 files are the minimum for Minecraft to recognize that that is a resource pack in your resource pack list here. So like if I was to go back here and go to resource packs, you can see that it has shown up here. That is what's required at a minimum to get that to work. We're going to dive into the display context first. So inside of our assets folder, we're going to have a Minecraft folder. And then a new folder that was introduced in 121.2 is this items folder with an S at the end. That is different than inside of textures and models. There's an item singular folder. This is akin to how blocks have a block state folder, but this is what you would use for items, where basically you can dictate all of your item definition stuff. This is where the majority of what we're going to be covering today is going to be living, is inside of this items folder. Something that is important to note here is that just like block states, Minecraft is looking for very specific named files here. So the things that are here need to be named the same as the namespace in game. So for example, cod.json matches if you have a cod in your inventory and you look at it and it says Minecraft:cod. That has to be the same so that the game knows that you're talking about the cod item when writing all of the information inside of here. So in the case of our cod here, we'll open up that .json file. And basically what this is saying is that we are going to select our model based on the display context. So when it's being displayed in our GUI or on the ground or fixed, which in this case fixed is what is called when it's in an item frame, I want to display this model, which is our 2D cod sprite. If that doesn't work, it will fall back to using our cod 3D model, which is basically saying, if we go back into game here, if it's on the ground, if it's in our GUI or in an item frame, it will show cod 2D. But in the context of being in our hand in first person, both left and right, being in our hand in third person, both left and right, or in some cases, if you are able to put it on your head, things like that, it will all display as the 3D model. And just as a caveat, actually creating these 3D models is not going to be something I cover in this video, though that is something I could cover in a future video if there is interest. I'll just give a blanket statement that Blockbench is probably the go-to program that I would recommend for making your 3D models. But again, this is not a Blockbench tutorial. Another really helpful resource I wanted to share for people who are doing stuff like this is on this website called Mezode, which is on github.io. I will share this as a link in the description for you guys. It is very helpful for people who are doing item model definition stuff because it basically takes all of the guesswork out of writing the syntax and whatnot. It's helpful to understand what you're doing still before tackling this. Like, it doesn't write it for you. You still have to know what you want to accomplish, but it makes it so that like it puts it in nice formatting over here. You don't accidentally miss any of your commas or things like that that tend to accidentally break your resource pack stuff. So you can even copy and paste stuff into this file here and it'll propagate over to the left or vice versa. So just to kind of go over again what we talked about, what I'll do here is I'll reset it to the preset cod. This is what cod looks like by default in vanilla Minecraft, if you were to just look at the files for that. What we're going to change here is basically say we actually want to choose, we want to select the type is select, based on our display context, which is the property that we're choosing to select our model based on. And then in the case, we want to change this to list, add a couple, and then we're going to choose GUI as one of them, ground is one of them, and fix is one of them, which again, fix is item frames. When that condition is satisfied, we would like to use a model, and I guess we'll just set it to cod right now. So that's just going to use the default cod item, but this is where you would put your link to wherever your model is defined. And then as a fallback, so again, if this condition is satisfied, it will display that 2D cod. If none of these conditions are satisfied, as in if it's in your hand or on your head, it will then use the fallback mesh instead. So in that case, we're going to just define the cod 3D model. And then all we have to do is just copy over here, and we can paste that into our .json file. Let's go ahead and double check our pathfinding and make sure that that's all set correctly. So let's head back to Minecraft, models, item, and then for me, I have all of that inside of this fish folder. So I have cod and cod 3D. We just need to add fish / each of these so that it can correctly find each of those models. And then just to show you guys what's inside of here, if I open up cod, that is just basically using the vanilla item generated texture, which creates a 3D thick version of our 2D texture. So that's doing it for the 2D cod, and then for the 3D cod, this is all of the code that defines the 3D model of the cod fish, which if I actually drag that into Blockbench over here, this is what that looks like with the texture and everything being applied. And then just to further drive the point home, if we jump back to our textures folder, this is where all of that is being pulled from for the textures. So you can see it's looking for fish cod 3D and fish cod for the particle. This is looking for fish cod, and those are all stored here. Where if you've never done a 2D texture before, sorry, a animated 2D texture before, that's what these .mc meta files are for. This is a little bit extra. There's tutorials that you can find online about how to do this, but basically this is how I'm defining the animation of the frame or the fish flapping in the inventory occasionally. So I know that was a bit of a whirlwind explanation, so I do want to just kind of highlight it and summarize things a little bit. Basically, the 3 required parts are you need, at a base level, you need textures to use for your model, which we have stored here. You need to actually create the model using those textures, which we have stored here. And then in that items folder, you want to have it here where you're basically calling upon those models that are calling on those textures. So that's the hierarchy there. And then just to reiterate, basically we're saying that we want to select the model based on display context. Our cases here are going to be GUI, ground, and fixed for the 2D. And then when that doesn't succeed, it will fall back on using the 3D model. So let's go ahead and move on from there to our next example, where we're going to take a look at using the axolotl variants to drive our custom textures dependent on which color of axolotl is in the bucket. So similarly to our fish examples, we're going to start with a texture for our axolotl buckets here. So if we go to textures, item, and then in this case, I have a folder called axolotl bucket where I've saved all of these here together. I have 5 variations of textures for the 5 variants of axolotls that you can find in game. If I head over to my models, similarly, I have 5 variants for those same 5 textures. And all these are doing here is calling on this similarly to the 2D cod. It's just looking for that Lucy texture, which in this case, Lucy is the pink axolotl. That's just how it's coded in game. And it's using that texture to generate that 3D thick 2D sprite when you're holding it in your inventory. So now that we have our textures and models defined, let's jump into the axolotl-bucket.json items file, where this is a little bit more involved than the last one we did, but similar in that we are using the type select so that we can select our model based on component information here, where component is now the set property. And the component we want to base it on is our axolotl variant. Inside of the cases bracket here, you can see that we have Lucy, Wild, Gold, Cyan, and Blue, which are the 5 variants here as well. And this allows us to define which model we want to use for each use case. So in the case of the Lucy, we want to use the Lucy model. In case of the Wild, we want to use the Wild model, etc. If we jump back on over to Meso just to show that from the ground up again, we're going to go type, select, property is set to component. The component we're going to be using is our axolotl variants. Cases, we want to be set to Lucy. Type, model. And the way I tend to work in this sort of hybrid workflow between Meso and Notepad++ in my case, I will tend to leave the model area either as like the vanilla texture or whatever, just so that I know what it's referencing, but I'll tend to add these in later once I'm over in Notepad, just because sometimes it can be harder to double check your work in Meso. That's just a personal preference on how I work. What we're going to do next is we're going to add a second case. So we have one for Lucy. Now we're going to make one for Wild. Again, type is going to be model, where we'll just do axolotl bucket for the time being. And then we're going to do this 3 more times until we have a case for all 5 of the variants. So just to double check, Lucy, Wild, Gold, Cyan, Blue. And make sure these types are all set to model, axolotl bucket, model, axolotl bucket. And then this one too. And then the final thing is, while it's not always required to use an item model fallback, in this case we are going to want to, because if we look in game, there actually is a difference between the axolotl that you can grab from the creative menu versus one of these that you're actually physically picking up an axolotl in the world. So if we didn't provide a fallback mesh, the game would not know what to do with these guys here. So back on over to Mesoid, we do want to define that fallback model. And I think we're going to use Lucy, the pink one, just because that's kind of the default vanilla axolotl. We're going to set that to axolotl bucket here. And you can see that it propagates up here in the top right. How nice. So we'll go ahead and select all of that, copy it, go back into Notepad and paste it in here. And then we just need to make sure that we add all of these correctly. So I'm going to add my suffixes here. And this is again going to be dependent on whatever you name your files. But in this case here, we've just named them axolotl underscore bucket underscore with the suffix of whatever type it is. And then also need to add a directory addition there because it's one file deeper than what the game is currently looking for. Copy these here throughout. And that should work. We'll go ahead and save. Reload. Which you can reload with F3 and T, by the way. I should mention that, I suppose. And you can see that it works still. B. That one's not like too much more complicated to understand, but there is a little bit more code involved, and so I think that's a good example just to show another thing you can do. Now to finish things off, let's take a look at our third and final example, where we'll take a look at doing stored enchantments as well as enchantments on items, and see how we can use those to drive different textures as well. So at the risk of sounding like a broken record, we're going to start with our textures and make sure those are first properly defined. For me, I have Enchanted Book as its own folder inside of Textures item, where you can see I have the Fire Aspect book and the Frostwalker book textures created. And then I also actually have a Tools folder, which is where my normal Netherite pickaxe and then my Fortune and Silk Touch pickaxes are living there. If we go back to our models, item Enchanted Book, you can see I have Fire Aspect and Frostwalker here. Very similar to what we've already done with the other ones here, except this time it's just calling on that Fire Aspect texture or the Frostwalker texture, respectively. And then the exact same thing here for the Fortune pickaxe. This is all pretty basic resource pack stuff, where it's just you've made a 2D sprite and you're using that generated parent, whatever there. No magic there, nothing crazy there. Magic comes more from the items folder, where we're going to be calling on that stuff. So if we look at our enchantedbook.json, you can see this gets a little bit more complicated. So instead of using the select type, and I don't know why it's coded this way, they seem to be very similar in what they're accomplishing, but for whatever reason they use a different type. We're going to go from Minecraft select to using Minecraft condition instead. So it's conditional rather than a selection. The property is still going to be component, but it has different uses for condition over select. The predicate we're going to use when we have that is going to be stored enchantments, which seems to be a pretty specific predicate for enchanted books, since I believe they are one of the only items in the game that can store enchantments. From there, the logic of this JSON file is pretty easy to follow, I would say. Basically, you're saying that when the enchantment Fire Aspect has a level of 1 or 2, we want to, when that's true, use the Fire Aspect model. And then the way that this has to work actually is that basically they're nested. It's not similar to the Axolotl where you kind of were doing each case like in tandem with each other. It's basically we check for Fire Aspect. If that succeeds, we use the Fire Aspect. If that fails, we move on to the next enchantment. And that actually hits back on what I was talking about at the beginning of the game, where if we had one book who had multiple enchantments on it, that hierarchy actually matters here, where because in our .json file we listed the Fire Aspect first, even if both Fire Aspect and Frostwalker are on the book, Fire Aspect will be the dominant texture because it's checking and succeeding for that condition first. So once it has basically said it's true that the book has Fire Aspect, it no longer cares about the Frostwalker aspect of this whole file. So I hope that's not too confusing to understand, but that's just the basic logic of the code. But if we digress from there and reiterate, Basically, when it's true, it's going to use fire aspect. On false, in our case here, I want it to look for a Frostwalker texture between the levels of 1 and 2. And then it's repeating the same code that we're seeing here, except on true now, we're going to use the Frostwalker model, and on false, we're just going to use the default Enchanted book texture. That's what allows us to basically keep this book from looking weird and untextured and broken, because if it doesn't have either of these two textures, if it doesn't have either of these two enchantments, which are the only ones that we have written conditions for, the game wouldn't know otherwise what to do with it if we didn't write this for an on-fail. To continue in the same way we did the other two examples, we're going to start from scratch here on Meezode, and I can show you what I would do here before bringing it over into Notepad+. So for our type this time, instead of select, we're going to be using condition. Our property is still going to be component. The predicate we're going to be using this time is stored enchantments, where on it we'll add a value. Using a string, we're going to look for fire aspect. For our levels, we want it to be an object and not I think this is an integer. This is if you wanted to define just a specific level of fire aspect, but in our case, we want any fire aspect to work, so we're going to use object. And we know that in-game fire aspect only has 2 levels in vanilla. We're going to set a minimum of 1 and a maximum of 2. And then on true, we're going to use that enchanted book underscore fire aspect. On false, we're going to repeat everything. So type again, we're going to do condition. Property is going to be component. Predicate is going to be stored enchantments once again. For this value, we're going to set it to a string once again and use Frostwalker with our level set to object, and again, a minimum of 1 and a maximum of 2. When that is true, we're going to select the enchanted book underscore Frostwalker, and on false, we're just going to choose the enchanted book. Same as before, we're going to copy all of that, bring it over into our notepad, and paste it here, and save. We'll reload our textures with F3 and T once again. And this is actually a good learning experience of what can happen if something is broken. Typically, it will be your syntax or something in your model file. So if we jump back over into the items.json, the enchantedbook.json file, what happened here is that we did not correctly link to our models. So if this is currently saying it's looking for a model in item / and then the model called enchanted underscore book underscore fire underscore aspect. But if we remember and go back to here, our models are actually saved in enchanted book fire aspect, and they don't have the name enchanted book. So let's fix this. That's how that should look. And that's how that should look, I believe. Let's go ahead and reload one more time. And you can see that that has fixed our issue with the purple and black textures, which basically denote when something is broken. Some kind of pathing is broken. Now to move over to our example with our pickaxes here, where we have it so that it shows a white band on Silk Touch and a gold band on Fortune pickaxes. It's similar but different from how we just did the enchanted books, and I'm going to show you guys over on Meezode. We'll go ahead and restart this back to default. And again, we want to do condition, property, component, and then instead of the predicate being stored enchantments, we're just going to do straight up enchantments this time. And then everything here should be pretty similar to what we just did for the enchanted books. But this time we're going to use fortune with a level of 1 to 3. And when that's true, we're going to use a model, which is looking for our netherite pickaxe underscore fortune. And when that's false, we're going to start from scratch again and do composite. No, sorry, not composite. Condition, component, enchantments, Silk Touch. And then in this case, because Silk Touch only has 1 level, I'm going to set it to int or integer and be that 1. On true, I'm just going to copy this model, paste it here, and then replace fortune with silk touch. And then on false, we want it to just be our netherite pickaxe texture. Basically, this looks the exact same way as the enchanted books did, except that our predicate is now going to be enchantments and not stored enchantments. We go ahead and copy all this over and open up our netherite pickaxe.json. We'll paste that in here. And then we do need to make sure to update our path again. For me, I have them saved in a folder called tools. I'm going to hit save. Go back into the game. We reload our textures. And you can see that it's working exactly as it's intended to. This system with your tools and weapons will follow a similar hierarchy that the enchanted books do, where it is displaying fire aspect over Frostwalker because we established fire aspect first in our JSON hierarchy. So for example, even though it's not possible in vanilla, if one of these pickaxes had both Silk Touch and Fortune, it would only display the gold because we established Fortune as our first parameter in our JSON file. So that's all the examples we're going to be covering in this video today. I hope it was enlightening and kind of gave you a good overview, at least at a minimum, of the new item model system and just a taste of what is possible. There's still so many new things that you can do that we can cover in future videos. Some of those things that I've included in my pack, for example, are being able to define models based on the duration of a use. And to put that better, you can basically make eating animations in 3D with your model. So for example, like while I was eating this fish, I can have it define a skeleton or whatever. That's just like that's probably a video that I'll do in the future that's more like specific about that, just because it's a little bit more in depth. There's a lot more moving parts and whatnot. But as a whole, I think this collection of things gives a good, overview of what is possible. One idea that I already have that I would like to cover in a video in the future is for something like this, where I have a cod, and if I eat it, there's an actual 3D eating animation where it reveals the skeleton underneath over time. That is a whole different system to anything we covered in this video today, and so I think it'd be a fun one to do in the future. If that's something you're interested in, let me know. If you have any specific questions for me about stuff that you want me to cover or clarification, whatnot, please let me know, because this is definitely a subject where there's just a lot of things that can be taught, and it's difficult to do in one encapsulated video. So we'll definitely be doing more videos like this in the future if you guys are liking that. But yeah, this has been a good overview of a few different contexts that we can use the new item model stuff. So thank you guys so much for watching. Hope you learned something. And again, if you have any questions, feel free to leave them in the comments below, and we will catch you next time. Thanks, everybody.